get started with the bulk of chapter 3. So as I look at the book has 3.3 and 3.4 split into 2. I really don't see the reason for doing that. So I put them together, 3.3 and 3.4. 0 is a polynomial, so we'll see all of the theorems and all of the stuff together. But what that means is we might break this lecture into 3 or maybe even 4 videos just so that it's not super long. But we'll put it all in order and get it all out here for you. So last time we were working with the synthetic division, and I was giving you values to plug into the synthetic division. I was saying things like, is x minus 1 a factor of the polynomial? And I said, how did I know to check 1, or how did I know to check 1/2? I mean, couldn't you just pick any number in the world and say, try 57 and see if that works? So there's a theorem that goes along with this. So we're going to get back into the synthetic division that we were doing, but before we do that, we're going to talk about 2 theorems and work with that. The first one, though, doesn't have to do with the synthetic division, and the first one is very, very important. It's called the fundamental theorem of algebra. And when a theorem says that it's fundamental, so if you're going to get into calculus, you're going to have the fundamental theorem of calculus, the fundamental theorem of arithmetic. Fundamental means that this is the building block. This is what we need in order to do what we do. But most of the time, the theorem is really dumb, but it's the absolute base piece. It allows algebra to be. And so what it says is, if a polynomial has n degree, so whatever the degree is of the polynomial, then the polynomial has n factors. Okay. Also called n zeros. And we'll see why that's the case in a little minute. But n factors or n zeros. So when I give you a quadratic equation with that x squared, so a degree of 2, there are 2 answers. 2 answers. There are no more than 2, there are no less than 2, there are exactly 2. When I give you a polynomial that has 82nd degree, that means there are 82 different factors to that polynomial, or 82 zeros. That's not something we're going to do, but that's the way that this works. So the fundamental theorem of algebra, and let's just write an example so you can see it. So if p of x, and I'm just making this one up so it's probably not something nice, is 4x to the 5th minus 3x squared plus 7. Now, even though this guy is missing a number of terms, that doesn't matter. Because he's a 5th degree, there are 5 factors, or 5 zeros to this polynomial. So what that means then is if we're going to do our synthetic division and try to find these factors, there are 5 of them that we're looking for. And like I said before, how do we know where to start? Okay, do I start with 1? Do I start with 7? Who knows? So this is how we know. So this is called, let's do a little squiggle here so we don't get lost. This is called the rational zero theorem. And it's written kind of weird. So it's a little bit hard to understand, but once I write it down and then I explain what it means, it will make more sense, I promise. So the rational zero theorem. So it says this: if P over Q is a zero of a polynomial, and I'm going to write this out, so it's a little weird, so I'm going to say P of x equals a to the n x to the n plus a to the n minus 1 x to the n minus 1 dot 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 a sub 0. So here we have the leading coefficient. And here we have the constant, and that's important here. So if P over Q is a zero of the polynomial, then P is a factor. It just occurs to me, I want to make sure that I write this down the correct way, so let me just look real quick before I write it down wrong, and then we have to go back and fix it. Okay, how did they write it? Let's get in the right section. Yeah, okay, so then P is a factor of A sub 0, and Q is a factor of A sub n. Okay. Now, like I said, it's written really weird, but we're going to use it in a way that actually will be helpful to us. So what it means is if we're going to go and we're going to try to do synthetic division to find factors, we're only actually interested in the first and the last term. So using this one, even though we're not going to solve this one, but just using it because we've got it on the board, we can say that if we have an answer that's a P over Q, okay, so, and that's the rational part of it, that it might be a fraction, and we saw last time that 1/2 was one of them, then P is going to come from this term here, the constant term, and it's going to be all the factors. So what are the numbers that multiply to be 7? And in this case, it's just going to be 1 or 7, but we're going to have a plus or minus. So you got to remember that negatives and positives work here. And Q, again, a plus or minus applying to the whole thing, is going to be a factor of the leading coefficient. So the numbers that multiply to be 4. So that would be 1, 2, and 4. And then P divided by Q will look like this, plus or minus. And what we need to do is make all the fractions with the P's on the top and the Q's on the bottom. So we'll have like 1 over 1, 7 over 1. Then 1 over 2, 7 over 2. Then 1 over 4, 7 over 4. And there's our list. We make all the possible little fractions with P's on the top and Q's on the bottom. And now if I did ask you to go ahead and try to do some synthetic divisions here, which I'm not going to, because we'll do one that I actually know what the answer is, okay? Then you would go off of this list. So would you ever try to do synthetic division with the number 6? Never. 6 isn't on our list. There's no way it's going to work in this polynomial. How about 1/2? Yep, could try 1/2. How about 7/4? Not my favorite fraction, but we certainly could try it. Okay, so this is the list that we're going to use, and that is your guidance. So let's erase here and look at a problem. So let's say that I asked you to find P of x equals x cubed minus 4x squared minus 7x plus 10. Okay? And we are going to find the factors. Are you going to come say hi?
Just putting the mower away.
Okay, more farm work is going on here, and the mower just came in. Okay, so anyway. So we are going to start by finding these little P's and these little Q's. Okay, that's where we start, and then we'll do our synthetic division. So we're going to use this rational zero theorem. Oh, the other thing is, how many factors or zeros are we looking for? 3. We're looking for 3. So the P's come from that last term, 10. All the factors of 10. So 1, 2, 5, and 10. Okay. Now the Q's on this one are really nice because the Q is just 1. So when we make all of the little fractions, plus or minus, It's just going to be 1 over 1, 2 over 1, 5 over 1, and 10 over 1. I just knocked over a shovel. Okay. So nice, we don't have any fractions we have to worry about. But now, if we are going to do synthetic division, are we going to use the number 4? Never. It's not on our list. We're not going to use it. So let's start smartly here. Don't necessarily need to start with the big numbers. Start with the small numbers. So the first number I see there is 1. So let's try 1. Okay, now we're going to put the numbers in here. Do we need any placeholders? No. So 1, -4, -7, 10. So bring down the 1. That's a 1. That becomes -3. That stays -3. Now we're at -10. Is this looking good? -10, 0. That worked out really nice, didn't it? Okay, and we used just the first number on our list. So we got a 0, so we can say 1 is a 0 of the polynomial. So that means, 1 is a 0, but it also means x minus 1 is a factor. Now, there are 2 more, aren't there? Okay. There are 2 more, and I'm going to show you where to find them. Once you get to what we would have here is a quadratic. Let's rewrite this. So p of x now, going from over here to over here, can now be written as this factor, x minus 1, and then the other factor is this guy, isn't it? So it's x squared minus 3x minus 10. So there's one of the factors. There are 2 more. They're going to come from here. And now that we have a nice quadratic, does this guy just factor on its own? So could we write this as x minus 1 and then factor this side? So we've got x, and 10 is going to be a 5 and a 2. And to get a -3, we'll have to go -5 plus 2. Does that look good? And now look at these numbers. Were those numbers that were on our list? Okay, there they are. So we have factored the entire problem, once with synthetic division and then using the quadratic factoring method. So there it is in its factored form. If we want the zeros, we would just figure out where each piece equaled 0. So that one's 1, that one's 5, and this one's -2. So the zeros to this guy are 1, 5, and -2. All right, let's do one more, and then let's do one more, and then we'll take a break or come back for part 2. Okay, so let's see what we got here. All right, that's not the one I want. Yeah, this is ugly, but let's go for it. All right, so let's say that our p of x is 18x cubed minus 21x squared plus 10x minus 2. And we're going to find the zeros. And remember, they're going to ask that interchangeably to find the zeros or to find the factors. Okay. This one's going to be a little bit crappy when we go to do the p's and q's. So remember, everything has a plus or minus on it. So our p's here, remember, are coming from this number. So the only 2 factors of 2 are 1 and 2. But our q's are horrendous in this case. They're coming from the 18, all the factors of 18. So that's 1, 2, 3, 6, 9, and 18. Not so nice. So now we have to create all these little fractions. So we're going to have 1 over 1 and 2 over 1. notice all of the rest of them are going to be fractions. So we're going to have 1/2, and 2 over 2 is 1. Then we're going to have 1/3 and 2/3. Then we're going to have 1/6, and 2/6 is the same as 1/3, so we don't need to write it down again. Then we're going to have 1/9 and 2/9. Then we're going to have 1/18, and 2/18 is 1/9, so we're good. That's our list. What a royal pain in the butt, okay? Royal pain in the butt. Now, I can give you one more piece of guidance, okay, on this one. When that first number is so large, and then the other numbers are large as well, okay, it's a pretty good bet. Not always, not 100%, but it's going to be one of your fractions. So I would say on this one, instead of starting with the 1 or 2, that we actually start with fractions. Now, am I going to start with the fraction 2/9? Probably not. It's not the prettiest of fractions. But just so that you see that there are negatives here, let's start with -1/2. Now, this guy, 3, 2, 1, 0, we don't need any placeholders, so 18, -21, 10, -2. So we bring down the 18. 18 times -1/2 is going to be -9, which together is going to put us at -30. All right. Then -30 times -1/2 is going to be +15, which puts us at 25. But 25 does not make a nice fraction, so this is ugly. So is this guy going to work? It's not going to work, is it? Bum deal. This happens, okay? This happens. I wanted you to see one that doesn't work. But again, don't lose heart. If -1/2 doesn't work, do you think maybe +1/2 might work? Okay, so again, start with nice fractions. So this time I'm putting +1/2 on the shelf. Same numbers here, 18, -21, 10, and -2. Bring down the 18. That's going to give us 9. Okay, 21 plus 9, or -21 plus 9 puts us at -12, which gets us to -6. -6 times 1/2 is -3. That is not what I meant to do. Sorry, brain fart there. Bring this down, it's a 4. Sorry, total brain fart. 4 times 1/2 is 2, and there's the 0. So 1/2 is a 0. We found it, okay? Now, where are the 2 other zeros going to come from, since there are 3 in total? They're coming from here, aren't they? So if we write this 18x squared, remember, drop it down by 1, minus 12x plus 4, can we set this equal to 0 and try to factor it or figure out anyway what the answers are to that? Now, if it's set equal to 0, the first thing I'm going to do is I'm going to divide everybody by 2. I wish I could divide by 4, but that doesn't work. So everybody's going to get divided by 2 just to make it smaller. So that's 9x squared minus 6x plus 2. And I hate to say it, but that looks like a disaster. I don't know. 9 and 1, 3 and 3. Let's use the quadratic formula. So we've got x equals, remember it starts with -b, so that's going to be 6 plus or minus the square root of b squared, so that's going to be 36, minus 4 times a times c, so 9 times 2, all over 2a, which will be 18. And now we're going to simplify a little bit. And we're not getting our calculator out. I do not want this in decimal form. I want to see it simplified. So 4 times 9 is 36, times 2 is 72. So this is going to be 6 plus or minus, and 36 minus 72 is negative 36 over 18. And Negative 36 is 6i, isn't it? So this gives us 6 plus or minus 6i, imaginary numbers are coming in here, over 18. And now it looks like everybody can get divided by 6, or we can factor and cancel out a 6. So it'll be 1 plus or minus I over 3. Everybody agree? If you cancel, cancel, and we'll leave a 3 on the bottom. And there are our last two answers. So our last two answers are imaginary. They didn't show up on our list, did they? They are not on this list. So guess what? We could have tried with synthetic division for a long time and we weren't going to find those other two, which is why using the quadratic there and the quadratic formula becomes a helpful technique. And the reason why they didn't show up is because the theorem was called the rational zero theorem. And rational numbers are real numbers, but these guys can sometimes have imaginary answers, okay? So we found 3, the 1/2, and then 1 plus I over 3 and 1 minus I over 3. So we're done. There is our answer. Woo. Okay, so stop here and we'll pick up next lecture. We'll do a couple more theorems and a couple more of these.